A race car tears around a winding track. Cameras placed at different points record exactly when it passes each checkpoint. By the end of the lap, the engineers know the total distance and the total time, making its average speed easy to calculate. But Stickmin notices something strange. The car wasn't moving at one constant speed. It slowed before every corner, accelerated down every straight, and reached completely different speeds throughout the race. The average tells the story of the whole journey, but it hides what happened at each individual moment. So a deeper mystery appears. How fast was the car moving at exactly 1 instant? Not 1 second before, not 1 second after. At that precise moment. It sounds simple, yet the answer seems impossible. Speed is distance divided by time, but an instant has no duration. If no time passes, how can anything have a speed? And yet, every bird in flight, every falling raindrop, every orbiting planet, and every speeding race car clearly has a speed at every moment. Somehow, nature knows the answer. Determined to solve the mystery, Stickmin begins shrinking the time interval. He measures the car's speed over 10 seconds, then 1 second, then 1/10 of a second. Every time the interval becomes smaller, the calculated speed gets closer to a single value. The answer isn't found by making time equal to 0. It's found by asking what the calculation approaches as the interval becomes incredibly small. The mystery wasn't hiding in time, it was hiding in a pattern. Looking for another clue, Stickman draws a graph showing the car's position over time. He connects 2 points with a straight line and discovers that its slope represents the car's average speed. But he still wants the speed at one exact instant. So he slides 1 point closer and closer until the 2 points almost become one. The straight line slowly transforms into a tangent line, touching the curve at only a single point. Its slope reveals the car's speed at that exact instant. Suddenly, everything makes sense. The graph wasn't just showing where the car had been. It was revealing how its motion was changing every moment along the track. Then Stickmin realizes something even bigger. This idea has almost nothing to do with race cars. Every graph tells the story of change. A steep slope means something is changing quickly. A gentle slope means it's changing slowly. A flat slope means nothing is changing at all. Whether it's a growing population, a cooling cup of coffee, the price of a stock, or a rocket climbing into space, the same hidden idea appears again and again. Centuries ago, mathematicians gave this idea a name: the derivative. Despite its intimidating reputation, a derivative is simply a way of measuring how fast something is changing at a particular instant. It answers one beautifully simple question: what is happening right now? That single question became one of the most powerful ideas in mathematics because the universe itself is never standing still. Today, derivatives quietly power the modern world. Engineers use them to design aircraft and guide rockets. Doctors use them to analyze heartbeats. Scientists use them to predict weather. Economists study growth with them. Artificial intelligence learns by making millions of tiny improvements using derivatives. The same mathematical idea that solved the mystery of a speeding race car now helps explain countless changes happening around us every second. Finally, Stickmin understands that the mystery was never really about speed. Speed was only the first clue. A derivative doesn't measure objects, it measures change. It gives mathematics a way to describe what is happening during a single instant, something that once seemed impossible to measure. The next time you watch a car accelerate, a leaf fall from a tree, or clouds drift across the sky, remember that every change leaves behind a mathematical pattern. The derivative is the language that allows us to read it. But if derivatives measure change, what mathematical idea measures the total effect of all those tiny changes put together? That's the mystery waiting in our next investigation.